All right, algebrists, here is our 10 practice test, chapter 10 practice test. I'll kind of talk through the answers to all these so that you can be prepared for tomorrow. So it says write the three proportions that can be used to solve for x using the side splitter theorem. The three would be top over bottom equals top over bottom, and I'll demonstrate that one in our example here. So that would be x over 2, that would be top over bottom, is equal to top over bottom, 16 over 4. Our next proportion would be top over whole side. I'm going to write WS for whole side, and then top over whole side. That would be x over x plus 2, right? That the whole side is x plus 2, and then 16 over 20. And then our third one would be bottom over whole side is equal to bottom over the whole side. So that would be 2 over x plus 2 is equal to 4 over 20. And then if we were going to solve for x, we would cross multiply. I think this is the easiest one to cross multiply with. We get 4x is equal to 32, divide by 4 on both sides, and we get x equals 8. Okay, so that's number one. Number two, we have to set a proportion where we go like 10 over 12. That's those two segments that make up that angle right there. 10 over 12 is equal to x over 6. Notice that the 10 and the x are lined up across from each other, and the 12 and the 16 are lined up across from each other. Make sure that is true on your proportion as well. And I get 60 is equal to 12x. So I divide by 12 on both sides, and x is equal to 5. X is equal to 5. All right. My next, number 3 is going to be the same thing, just with a little bit more variable action. So I'm going to have 4 over 6 is equal to x over x plus 1, okay? I'm going to be cross multiplying again, so 6x is equal to 4x plus 4. Subtracting 4x on both sides, I get 2x is equal to 4, which means x is equal to, divide by 2 on both sides, x is equal to 2. Okay, everybody see how that kind of worked out there? All right, at number 4, we go 10. Oh, let's go 9 over 10. 9 over 10 is equal to 3 over, this segment right here is all of x except for 3, so x minus 3. We can cross multiply, we get 30 is equal to 9x minus 27. Add 27 to both sides. I get 57 is equal to 9x. So I can divide 57 by 9. We are not. We're going to lacrosse. Take me a second. All right, and then we divide by 9, and we get 57 over 9.
Where's the lacrosse game?
At home. Number 5, we're going to be doing a similar thing to number 1. So we're going to be setting up one of those proportions. I think the easiest here would be, it looks like it's primed for the bottom over whole side. So we got 2 over 8, right? 6 plus 2 is 8, is equal to x, or 4, sorry, 4 is my bottom, over x minus, or just over x, because x is my whole side. There you go. 4 over x. We can cross multiply, we get 32 is equal to 2x, and then divide by 2 on both sides, and we get x is equal to 16. 16, we get 57 over 9 here. All right. Our next one is number 6. The proportion we want to set up there would, I think, again, be a bottom over whole side or top, depending on how you look at it. So 10 over 18 is equal to x over 14. Cross multiply, 18x is equal to 140. Divide by 18 on both sides, and x is equal to 140 over 18. What is 140 over 18? Simplified. That'd be 70 over 9. 70 over 9. Okay, so x is 70 over 9. The next one is number 7. We can actually write this as 19 over 3. I must have to simplify that one. 19 over 3. Our next one is number 7. And that one is another side splitter theorem question. We know those are parallel because those are 90-degree angles. So we can go small side over, so like this small side of the small triangle over the whole side, which would be 10. And then this small side of the small triangle over the whole side, which would be x, right? So we're going to have to go 6 over 10 is equal to 8 over x for this one. Okay, then we'll have 6x is equal to 80. 6x is equal to 80, and then we divide by 6 on both sides. And we get 80 over 6. X equals 80 over 6. And that simplifies down to 40 over 3. Okay, so we had a couple improper fractions here, but we are in good shape in terms of setting things up. Number 9, closing out our page with number 9 and 10 here. We have, looks like, again, a small side of this triangle. This is a small side of this triangle, so I have 10 over small side over whole side, 10 over 14, right? 10 over 14, so this small side over the whole side is equal to this small side 12 over the whole side, which is x. So I'll get 10x is equal to 168. And then 168 divided by, oops, I'll show you my x, divided by 10 would be 84 over 5. Again, you can write these out as decimals on your test. I don't really care. I just prefer improper fractions. So I think they look nice. 84 over 5. Number 10, kind of a trick throwing you off here. We got two similar triangles, right? Because of angle, similar triangles. So we are looking at maybe 3 and 4 are corresponding sides right there. So we can set those up in a ratio. If I'm trying to find x, what corresponds to x? Looks like x and 10. So x is on the small triangle along with 3, so those both go on the top. So small over large, x over 10. Cross multiply again, we get 4x is equal to 30. Divide by 4 on both sides, and x is equal to 15 over 2. And that's your answer. Then we'll get through the rest of these here quickly. Number 11 says solve for x and y. The triangles are similar, so we have to set up another couple of proportions. So we have 10 is on the large triangle and y is on the small triangle. Those are corresponding. So is 16 is on the large triangle and 4 is on the small triangle. We can go ahead and cross multiply. We get 40 is equal to 16y divided by 16 on both sides. And we get simplified fraction, 40. We would get 5 halves. So y is equal to 5 over 2. We'll note that up there. We can go ahead and solve for our x then. So x is on the large triangle, 3 is on the small triangle, so we're going large over small, large over small. Then we gotta go large over small with our 16 and our 4. So we're gonna go ahead and cross multiply again. 4x is equal to 48. Divide by 4 on both sides. 48 divided by 4 is going to come out nicely. I know it's going to be 12. X equals 12. 12, number 12, we have a similar situation. We got y and 21 are in relationship there. Y is the, looks like the smaller triangle, because we're going small over large this time. Y over 21 is equal to our known sides, which would be 18 and 6. Those are as well corresponding. So 6 is our small and 18 is our large. So we cross multiply. 6 times 21 is 126, I believe, is equal to 18y. 126 divided by 18 is 7. So y is equal to 7. And then to find our x, we're going to do the same thing. So x is corresponding to 2. So we're going small over large again, or large over small this time. Large over small this time. Large over small. X over 2, and that's, we can use 6 and 18 again. We would go 18 over 6. Okay. Cross multiply, we get 6x is equal to 36. Divided by 6 on both sides. We all know that equals x equals 6. All right, for geometric mean, we choose the two numbers, we multiply them, and then we take their square root. So that would be square root of 81, which is 9. This would be 18 times 9. Which is 172, 162. 18 times 9 is 162, so square root of 162, which I know 81 times 2 is 162. So I'd have 81 and 2 in the parentheses there. And then I would take the square root of 81, and I would get 9 square root 2, and that's my answer. So you're going to want to rewrite this guy as its factors of one of those factors has to be a perfect square. And then you take the square root of that perfect square, 81, and you get 9. Okay? This one asks, are the two triangles similar? If yes, it is it AA or SAS? So we're looking, are they similar? We know my triangle angle sum is 180. I already have two matching angles, so I can go ahead and go 105 plus 21, and that would be 126. And I think what's 180 minus 126? That is 54. Therefore, I am matching up because this has to be 54. That means this one has to be 105. So those are an angle pair of similar triangles. 16. We got a couple of 80-degree angles here. We also know that this side's 4, this side's 3. This side is, this side was 6 and this side was 8. So we're thinking those angles are similar. That's good. That gives us an angle part. And I see that 4 and 8 are in proportion there. 4 times 2 is 8, and 3 times 2 is 6. So therefore, I have side angle side similarity done. Lastly, like the ones we talked about in class, I'll do these on here as well. Pentagons below are similar. The vertices are all in the same position as seen here. So we can set up a proportion with corresponding parts, 3 over 5 and 9 over x. 9 and x are in the same-ish place, and 3 and 5 are in the same place. Cross multiply, we get 45 is equal to 3x. 3x. Divide by 3 on both sides, we get x is equal to 15. So we'll add that there. It says, what is the ratio of their perimeters? So then I think the ratio of the perimeters is the same. So ratio of P is equal to ratio of the sides. What's the ratio of my sides? That's 3 to 5. So the ratio of my perimeter is 3 to 5, 3 over 5. Or you can write it as 3:5. That would be appropriate as well. It tells us the perimeter of the larger figure is 50. I don't know why they didn't print on your worksheet, but the perimeter of the larger figure is 50. So this plus this plus this plus this plus this is 50. We can find the perimeter of the smaller figure using that, okay? So if the perimeter of the larger figure is 50, so we can go 50 over, trying to find the smaller one, so 50 over x, right? And then what is the ratio of my perimeters that I can set that equal to and solve? Oh, it is 3 over 5. So the 5 is the larger one, so that would go on top over 3. It doesn't matter if you flip it upside or down or anything like this would be the same thing. X over 50 is equal to 3 over 5 would be the same thing. You can solve it that way too, okay? All right, so cross multiply, 5x is equal to 150. So divide by 5 on both sides, and x is equal to 30. So our perimeter of our smaller figure is 30. Okay, so then we can solve the area of the smaller figure using our area ratio. Our area ratio is always the ratio of the sides, which when each of those are squared. So we would have 9 over 25 is our ratio of our areas. Let's say ratio of areas. Ratio of areas. And then we can go ahead and say that ratio is equal to the ratio that we know. We're given smaller figures 45, so I'm going to set that in line with the smaller figure ratio 3. Smaller figure part 3, 45 over x. Right, because we're trying to find that. That's x right there. We're trying to find larger figure area. And then we can go ahead and solve this ratio here. So cross multiply 9x is equal to 25 times 45. Nice even 1125. Divide by 9 on both sides. That gives me x is equal to 125, and that's how I find that. So that is the whole practice test key. The PDF key is also online if you want to see that, but that's all of those explained and shown. Your actual test will be very similar, and that will be tomorrow. Thanks for watching.